enough to present a topic of such a depth and vastness, like each and every term in this particular topic, impact of AI, security on embedded system. Each and every topic needs to be considered in its entirety. And for basically, my background is like I'm a, as is like mentioned, PhD in acoustics and working on some systems. So I have seen, just like a blind person seeing an elephant, feeling elephant. I have seen different aspects of all these things playing out in the products or the solutions that we are working out. But that no way makes me a right candidate to present this thing, but I'll try my level best to give an overview and whatever things I could learn from my team members related to this particular topic over here. So overview of presentation is like basically I'll just introduce Xalten systems and some of the products that we are working just to show that maybe I may, if I told, if I have to refer to some examples during the discussions, I may use some of these examples. Uh, so, so it's going to be a generic overview. As I mentioned, this topic is quite vast, and each area, each bullet points or the listed items, can take actually you can actually dive into that one using like kind of like a day's kind of depth. But unfortunately, I'm not the right person to do that one. Anyway, I'll try to give whatever things I have learned over running this project. I'll try to explain those things over here. And I would like to acknowledge before going to the presentation the support that I have received from my team members in preparing these presentations. And if at all there are any questions or anything which basically dives into depth, I'll be more than happy to connect with the technical team and they'll be able to give you the right answers or the directions to go further. And with that disclaimer or introduction, let me start. Just a brief introduction of Xalten system. We are a technology startup. So there are a couple of domains in which we are working. One is precision automation, and the second one is engineering services. Second one is sensor systems. Engineering services are there, but not into a significant portion of our work. So in the precision automations, basically we have a couple of products. I'll just go into the details just to show we can place machines for fluid dispensing, reflow ovens, and the semiconductor domain, some equipments that is enabling the processes, die bonding and wire bonding. We don't have that yet, but we are in the process of slowly cooking up things to bring something up in that domain also. Underwater domains like underwater acoustic system, mostly navigation and communication systems, which will enable autonomous platforms. So that's idea with which we are working on. Multiple products we are working on that domain. So that is in short about what we are working on. And just to give an idea of the products that we are working on the electronics assembly segment, basically you all know, like basically we're working on the electronics domain now, like now with the SMT components and components of as small as like O201 or even smaller than that. Hand assembly is not an option. So you need some sort of precision automation to do that. So what we have come up with is like a series of machineries and tools which will enable you to do the assembly in-house. This can also be used as an ideal platform for learning or training people on PCB assembly also. This is one of the products. So in all these products, these all are like independent machines which basically functions like individual tasks it has to do by its own, and with minimal intervention from the users, especially when it comes to reflow. When there's a complete control system which basically monitors the temperature and controls the temperature as required, or a automatic feeder system, depending upon the situation. Bear with me, there's a lot of election campaigning going on here. Maybe if the noise is coming there, just please bear with me. Uh, Automatic feeders, they're also like the system has to sense what is happening there, and based on that one do next actions. There also some sort of intelligence has to be there. And in the pick and place machines also, before picking the components, you need to know whether the components is there or not. So in these areas, you need to have some systems which can work efficiently, effectively, at the time cost effective. And now coming to the underwater sensor systems, we are working on transducers and some sort of like Doppler velocity log is one of the products that we are working on. Basically, measures the velocity of the underwater platforms, and which provides navigation aid. Echo sounders are something similar, which basically does the measurement of the depth so that the navigation can work properly. And wireless communication system, definitely it enables people to communicate underwater. And some of our core strengths is listed here. So with these products, each and every product, at least we are dealing with embedded systems left and right. But during this development, some of the constraints, like what all things, I'll come to that one. So all this talk is based on what all things that we are learned from that one. But when it goes to the details of the presentation, mostly I'm just giving generic guidelines based on what is available, where we can look at, what is the next direction to look at for that thing. So now, coming to the embedded systems, hope I am audible even now. There's some power failure at this place, so hope connection is
Yes,
still
yes.
on.
You
Yeah.
can go. No problem.
Okay. Yeah. So one of the as I mentioned, I'm coming from a different technical background, mechanical engineering background. When I started my career, I was just wondering, like, what was the difference, like compared to a normal computer system? It also has some intelligence. You're doing some processing there. Then what makes it embedded system really special compared to a normal computer? So just to, based on my understanding as a layman's perspective, I would say like something made uh, something made as an optimized solution for a specific application cannot be a good generic platform or flexible platform. So that is, in short, for me, that basically captures the essence of going into the embedded system. Embedded system, mostly when you're working, you're trying to optimize. You're kind of like things that you're trying to achieve there is kind of like you're not going to aim to make it a very flexible platform where anything and everything can be done. So it mostly goes into, you see embedded systems left and right in most of the things that you're dealing with in day-to-day life. Any TV, nowadays TV or any of the things that you are operating at home, any appliances, everything is kind of like an embedded system which will have some sort of embedded logic or embedded intelligence in that one. And basically that collects information from sensors and takes decisions or react to our inputs. But these systems needs to be very cost effective, especially when it goes to the white goods or especially when it goes into a mass deployed system. It needs to be cost effective. So when we prioritize the functionality and optimize the performance, and it needs to be reliable. Like you cannot keep many things open so that one fine day in the middle of doing something, it cannot break and give you trouble. So these things becomes priority. So yeah, so just for guiding points, I've given the points here. Uh, but the strength, usually, typically, when you take any system, their strength often becomes their main weakness also. The same is the case with the embedded systems also. Like the strength associated with that one also contributes to their weakness. Usually, when you cost optimize and tune it for specific performance, again, you are definitely going for a constraint system where performance is very much like even the last bit of juice you try to squeeze out from the system to get the maximum performance out of that one. And often implementation, for example, if you straight like a compute platform, or just many people opt for compute platforms like uh, Raspberry Pi or anything for to develop embedded systems. There you get the flexibility, but when you're going for a bare metal kind of approach, the kind of implementation becomes much more tedious. especially you are dealing many times you are dealing with many of the peripherals directly. The communication protocols, whatever that you are going to use, we may have to, even sometimes you may have to directly deal with the registers and all those things. Debugging becomes quite challenging often. And many times when the stakeholders, convincing the stakeholders, like you are developing something and the end user is someone else. So for him, already a system is developed. For example, one of our customers in one of the monitoring system, they want to add one more parameter to the list, which basically sent over the internet or whatever communication platform that we are using so that they can monitor. But the thing is that looks like we are already sending three numbers. Why can't we send one more number? But many times we are almost like the registers, the memory allocation, all those things almost up to the brim. We may not even have enough space to add one more variable. So these kind of systems like becomes like additions and making it expanding the scope after the design becomes a significant challenge when it comes to embedded system, or when you're going to implementations where it is kind of like a highly resource constraint. And so this is basically gives the characteristics and constraints when it comes to embedded system. Now let us look at when we add security into the mix. So you can make it to work. You can make the systems to work, but you also want the system to be secure. Unlike many systems, like our personal laptops or anything which we are always holding on to us, embedded systems are not always like that. Most of the time, it is physical. Even people have physical access to. We may not be able to prevent people from physically accessing the systems. So even from that point onwards, we need to consider like the security aspect of system. The typical the concept is root of trust. That is basically hardware anchored security system, which is basically like you build from the very basic layer, you start building the security into the system, and you build one layer over that one, next layer, next layer. Make sure that the entire thing as a chain, if any line in that chain breaks, things goes for a toss. But if you, as long as the chain is maintained, you kind of ensure security of the system through the design itself. So for example, like the hardware, before the hardware device load the booting things, whatever the bootload or whatever things that basically you use signed things for that one. So that you basically authenticate the booting, you make sure that you boot only the certified or authorized thing, so which has capability to ensure whatever layer you are loading next to that one is kind of like secure. So then after the boot, like when you load the OS, the boot loader, whatever things that you use for that particular application will have necessary features to make sure that you are loading a secure system into that one. And so you will basically use only trusted OSs from launching. And once the OS, this typically that is also currently like a long back, this was not there. Now even all the PCs, everything has secure boot also. So next stage, it goes to the the OS, basically whatever OS that you're trying to use should have enough features to make sure that the application that you are going to load is also should be secure. And then you should have some features and everything in the application as well as in the OS to make sure that during the execution, that basically prevents any unauthorized things. Once you maintain this particular entire chain, you kind of like, this is basically a simple, but if you follow this particular protocol throughout the system, the root of trust basically ensures your system is protected. And so this has to like nowadays, like over there, the updates or physical updates, whatever that we are going to do to the system, that should also be taking care of this sort of trust thing seriously. So during development, what happens is like we want to change the system left and right. So we may provide many features which makes the system very vulnerable. But we need to, during the early stages of design itself, like this is something very important, because if you don't consider this particular aspect during the design stage itself, we may keep many ports open, which leave doors for others to come and tamper with the system, especially when you're working with some mission critical or some systems which are kind of like where you cannot prevent physical access to the system. So these things becomes very, very, very critical. And so some of the hardware things and some of the things like trusted platform modules, like trust fund, basically asks us a safe wall in which you can operate many hardware accelerators, like crypto-based hardware accelerators like crypto cells and all those things. So where all the encryption, decryption, these kind of things can happen. Even like some of the cases, you can have a different operating cells in which some places you have that things which operate on the general things, and some cells which will only, there'll be a always check happening. Something which is core to the security will happen only in this particular segment. Those kind of separations can give you some sort of secure, like a overall framework for the security in the embedded system. Now, things are changing. Like with now, intelligence is also like a kind of synonym with AI or internet connection. This has become even more critical. Like now, IoT is also synonymous with embedded system for many of us. So previously, this is not the case. Like once you build the system and once you make it tamper-proof, yeah, it's kind of done. It's kind of secure. But with the arrival of IoT, you need to have a connectivity. Also opens all sorts of open ports or doors for. It opens up a different kind of challenge. So in a broader sense, we can consider like we need to look at the security from 4 different aspects. Basically, the hardware should be secure, but you cannot avoid communication. So you need to have a secure communication. So to whomever you are, because when it comes to IoT, if there's no communication, then it is not an IoT device. So basically, you need to have a secure communication. And which are things that you're connecting to your IoT device, the cloud or what your server. So there also you need to have a security system. And the fourth aspect when it comes to is like the in between, you may also want to update the system. The process that you use for the updating, that also should be very secure. So if you take care of all these things, your embedded system, you can kind of say that you kind of considered all the aspects to at least make it, you have put in all the non-defense mechanism to make it secure. Yeah, what all things that I have mentioned, it's already there, the secure booting, encryption. Yeah, one more thing is like, even when you are looking at an IoT device, as long as possible, if you need to send only data, if there is no need to receive data back, it's always better to prevent the connections coming back into the device. That way you can also like if it is not required, like that is one good way. Most of the systems operate that way, so you can initiate your connection from your device to the other one, but you don't you will only connect to trusted parties, so in such a way that you prevent unauthorized entry points into the system. And now like challenges, when you look at an IoT system, the kind of challenges that you face like basically again resource constraints. When you're trying to implement something, when you're going for a low cost, highly optimized platform, you are always constrained by the resources. The kind of crypto schemes that you can use is also very limited. There are some techniques or lightweight solutions which are available. My team has listed it over here. Then when you have a wireless or other wired connection, man in the middle attack, eavesdropping, all those kind of things are there. So what are the techniques to use to prevent that one? And one of the big challenges like trust chains, complex trust chains, like when you have, like if you want to prevent somebody eavesdropping, how you share the security keys. Can I have a security key shared through not to the same channel where which I'm communicating? So that is another aspect we need to look at, so that somebody who is trying to eavesdrop into the system can be prevented. And unattended deployment, yeah, that is something like I already mentioned. That is one of the biggest risks. Secure boot, hardware root of trust, then tamper-proof design. The moment you open the device, breaks or something like that, kind of things can be implemented. Yeah, the onboarding, that's what I was mentioning. Onboarding and key provisioning. Open wireless channel. Can we have a separate things, like when you're connecting to a Bluetooth device, you have a key which is being shared, which is being shown to you on a phone, like 2351 is the number to be entered or something like that. Verify the number is 2351 or something like that. So that communication is not happening through, somebody has to see that number and key in that one. That is not happening over the same channel in which the wireless communication is happening. That way you bring in additional security, so that somebody who is trying to break into the thing or trying to do some nasty things won't get access to that one. Then again, the challenges are how to effectively, if you find some risk in the system, how to update, provide patches. So what should be the protocol? Everything should be built into that one to address that. These are the challenges associated with that IoT service. And this is again just for information only. Numbers, this slides I'll share. Basically, I'm not an expert in any of those things. These are some of the encryption. Again, this the ways as we most of the time embedded systems, not most, many times embedded systems which are used for unattended access may operate on batteries, and sometimes power constraints is also a problem. So many times, not just the uh, hardware cost, sometimes the power is also a major constraint many times when you are designing and operating systems. So that also sometimes affects the selections, what are choices that we have. There are many cryptographic and encryption techniques, hashing algorithms in place. The lightweight versions, alternatives are also there. So these are just for reference, quick lookup kind of things, depending upon the kind of applications or the layer in which you are operating. Now comes the next aspect when you add again AI into this thing. So far we talked about embedded system constraints, and now when we add the security into the embedded system, how it changes the entire metrics. Now, when we are going to add up AI into that one, that brings up a new, different set of challenges. People say kind of like AI is kind of like a black box kind of system. It's like our conventional systems, we have a hard-coded algorithm. We know the logic where we want to test it, and we kind of test it. We many times we know the edge cases, and we can kind of test it with all possible scenario and say nearly all possible scenario and say that we are kind of verified the system is fine. But when it comes to embedded systems with the AI at edge, you always anyway for people. I think most of you are much more conversant with the concept of edge and AI at edge kind of things, like but many times my applications, it is like a large chunk of data cannot be transferred left and right through the internet to a cloud, then do the decision cannot take place there, and the time delay between these two things may not be meeting the operational requirement. So it's always good to have some sort of intelligence built into the system so that the decision can happen straight away there. And the necessary things that are learnings, that what are things that necessarily need to be communicated with the cloud can be communicated. So that is a concept basically. There are many things which may contribute to this thing. Sometimes the latency may be an issue. Sometimes the amount of bandwidth that is available for communication may be an issue. Sometimes even the power requirement may be an issue. So all those things can contribute to this thing. Or even the cost associated with the edge system, that could also be a constraint many times. But when it comes to AI, like as I mentioned, you cannot always test for the 100% use cases. So you may once in a while experience some sort of outlier, for which you may need to pass the information back to the server so that the server can work on this with this new information and come up with the updated deployment scheme or the updated AI edge algorithm or whatever things that you want to. This always brings in this back and forth communication requirement, mostly 99.9% of the cases. When it comes to AI, you need to have this kind of requirement is there. You cannot avoid that communication requirement. And that is something that brings change to the entire this thing. And there are many sophisticated attacks. Like basically, it's also coming from the security things. When you go into the AI system, there are many trained systems. There are many different ways they attack. So I'm not familiar with this. I've just read through many of those things, different ways people can break into these kind of systems by injecting or even the manipulating the training process or injecting something malicious things during the training itself to make sure that these things can be activated at some other point of time. So these kind of things will additional things which I'm not touching upon, or I'm not qualified enough to touch upon those kind of topics. And when you are trying to deploy AI, like basically the computational limitations on the embedded systems basically requires you to prune your system, really, whatever things that you have developed on your existing database or decision process, whatever things that you have developed, that needs to be fine-tuned and compressed and made into a very compact form factor, which can be taken up by the system, the embedded systems, which runs on a limited resources. TinyML is one such thing. TensorFlow, Lite, Micro, those kind of things you can export. This allows some of the algorithms, AI algorithms, to be implemented on the edge. I think, yeah, most of the points I want to talk about this thing, I think it's already covered here. Now, many cases, you may also have to depend upon cloud for some information processing, and as I mentioned previously, over-the-air updates are essential for such systems, because whatever things that the new inputs that you have gained from the system operation in the field, that needs to be churned into our existing processing pipeline and see what improvements that you can make to the system, and then that needs to be updated. So there should be some provisions for this thing, and then additional security aspect when it comes to very mission critical things, like if you are you don't want any false sensor data to coming into your AI system, so you need to authenticate. You may have multiple systems in a big complex system like autonomous car or anything like that. It might be communicating with multiple devices inside that one. So all the data stream that it is receiving, that needs to be authenticated. Like that needs to be like some sort of certification should be there. It is the relevant data. So otherwise somebody can hijack that thing and put in wrong information or simulated information to do some unwanted things with your system. So these are some of the things that needs to be very careful when you are sending your system in a autonomous mode, completely autonomous mode. When you are running a system, these things becomes very critical. You need to make sure that everything happens within the stipulated time frame that is allowed for that one. There should be a secure channel by which you can update the system and account for the deficiencies in the system. And you should also ensure the communication between different subsystems and sensors basically are kind of like uh, take the you take care of the possibilities of somebody can come and tamper with that. And now coming to different possible options that is available if you are trying to make some systems, basically embedded systems and edge systems. There are some of the platforms and tools that is available to you to make. Some examples are also given here and typical use cases. We use AI in our vision processing system in our pick and place machine. Basically, when we peel the tape, the component comes in a feeding tape. So tape, when we peel, sometimes we may miss some components. Some components can fly off. Sometimes during the manufacturing of the tape, glue may get in stuck with the tape, and sometimes these components will get stuck to that one and get peeled off with the tape. So during the pick, like when the machine goes to pick a particular resistor or capacitor, if it is not there in the pocket, you are wasting cycle time there. So just to avoid that one, we use vision processing before going. We just go to all the locations and make sure that the component is there before we go and initiate a pick. So in our case, luckily, we are not doing this on an embedded vision processing system. So we kind of have the flexibility there. But we can always very well implement that thing. So just to give one of the application cases where we have been using this thing. Now, this is a different sort of looking at the system or the embedded system per se from a different aspect. So the way in which people have been working on the embedded system development is also kind of changing. There is another impact of AI onto embedded system development. So AI aided development. So there are some softwares like I think Flex or something. I forgot. Yeah, I think Flex AI. There are multiple solutions like that, which basically even the PCB design they can give. Nowadays, you don't straight away go to DigiKey or Farnell or the Element 14 or RS components and put a number of filters to come up with the right ADC or right modules that you require for this thing. So you kind of initially ask any of these generative platforms. A hell of a lot of work is happening behind the scenes. Like they are employing some of the best brains in the industry to write up technical articles and technical know-how, basically consolidating the know-how information. That is why these platforms are able to give near perfect answers to most of the queries. That is one way, even from how it is going to affect the workflow, how we are selecting this thing. Even after selecting the components and preparing the schematics layout, this thing can help significantly. Automatic layouts, or initial footprint to start with, all those things, this AI platforms will be able to help you. And embedded programming side, what register to write, what code to write, what command to use, all those things, rather than now running through 100-page document. Nowadays, people just put it up into the LLM, whatever things that people are using, and ask queries. But be also cautious. Sometimes the answers you need to cross verify with the documentation. Sometimes it can go wrong. Happened in one of our cases. So not connected pin. Instead of connecting the clock, we ended up connecting one of the pins to one of the communication not connected pin. Instead of connecting the clock, we connected to a not connected pin in one of the BGAs. So there's nothing I could do afterwards. The entire run is run kind of. I just had to throw it in the bin. So this kind of things can also happen. So we just need to be very careful when we are dealing with this kind of things also. But it significantly helps in preparing the draft or coming up with the initial plan, everything. But Having said that, it is our responsibility to make sure that we just go through each and every aspect and make sure that things are in perfect order. So this is another way to look at this thing. Yeah, I think that kind of brings to the end of what all things that I have to say on this particular topic. And again, uh, here I would like to acknowledge the help from my team members for preparation of the slides and contribution to this slides. I'm not an expert in this field, and I'm open to questions wherever I can give any input from my side. I'll definitely more than happy to provide that one. Otherwise, I'll connect you with the right people to get the answers for that one. Thank you. Thank you for your patient listening.
Thank you, Unni. I have some questions. I think these are questions you can answer. So first of all, as a startup, IP is also important for you, right?
Yes.
Have you in the startup world is like IP theft is it a concern or like you are
No, it is a
how
concern.
serious?
It is a concern.
Uh,
It is a serious concern because so IP theft is a serious concern. For example, you spent a number of hours preparing not only on the software IP, even the hardware IP. You spent a number of hours considering which all masala items you need to mix together to get the perfect curry. You find out all those things and make a perfect curry. And unfortunately, it is not in like a different curry, everything is mixed together. You cannot know which is the ingredient that has directly gone into this thing. This is like all is lying separately right in front of the plain eye. Somebody who really wants to duplicate and recreate that thing, that is a major concern. And another constraint is like most of the time when you're developing the hardware, many times, considering the time constraints and all those things, you pass it over to third party for manufacturing. For example, you do the complete design, and if you are also giving the assembly also outside to somebody else, you are almost giving the complete design. Happy, you take it away. Thank you. The other person can have a good repository of all this information, whatever design that you have done. So that is another concern. That is one reason why we went into development of pick and place machines. Frankly
okay.
speaking, so our initial area was to work on sensors and sensor-led advanced systems. So, but when we started working on this was a major constraint for us, IP theft or IP loss. So then we thought like, how can we prevent that one? That's when we went into developing a pick and place machine where we can do the assembly in-house. So that is one thing. And again, software. What are things that you're developing nowadays? Like even if it is executable, if you have access to that one, people can decompile it. People can do all sorts of things, and even what I understand is like even this all this if you pass the decompile thing onto a ChatGPT or something like the generative platform, it is it can give decent enough information on the architecture and what all things that has gone into this thing. It has gone to that level. So tamper-proof things, maybe the moment you try to access it, it should. So those kind of things has to be there in most of the devices. So IP theft is a serious concern. Yes, you have
So
rightly.
right now, is it like we'll just go with the flow? Is it like that or
Mm,
okay?
no, serious. Unfortunately, the case is like core work in the deep into the IP work is happening not even not in every startup that you see around. Most of the things what is happening in Indian scenario currently is like you kind of get systems from XYZ persons, integrate it and
That's all.
provide us a solution. There you are working as an integrator, and many it's hard fact, but many cases even that place also there's not major IP development happen. But unfortunately, in our case, we are starting from scratch and going into the depth, like even to the minute, even to the materials. We are exploring and coming to come up with solutions for that one. So there, all even electronics, even the signal processing algorithms, we are developing from scratch. In the scratch, in the sense, it's not like I'm inventing totally new mathematical process or anything like that. Our team is trying to identify right processing steps and stitching them together. At least that stitching them together part is our IP, and how to program it such a way that a low power platform can run it. That is our IP. So those things we don't want to give away
Somebody,
easily.
yeah.
Yeah. So that there we are seriously concerned about IP theft.
Okay. Then another question is regarding the point which you were discussing last, and there are many students, I think, in the among the participants. So, how to use the LLMs for supporting your development, but so what is your what is your I won't say advice, mix suggestions to them? How can they? Because as you said, errors are going to be there. So how to be cautious and how to
Yeah.
your
So
take on that?
basically, I mean, first of all, disclaimer, I'm not the right person to answer that query. Again, I'll try to answer it from whatever limited things that I know. Definitely, you cannot say blind eye towards the development happening in the field of AI and say that you are not going to use it. That is a nonsense thing to say. I wouldn't say nonsense. It is not something which is aligned with my thought
Mm.
process. We have to make use of what all tool that is available to us. At the same time, we should also be aware that what all things can go wrong there. As I mentioned, you cannot just because it comes in the information comes in a properly formatable, believable,
Mm.
a way, authentic way. Because the one problem with us is anything that is printed in a newspaper format or a book format, we kind of take it granted that
Table
it is truth.
spreadsheet format are all.
Yeah, absolutely format. We take it granted that it is authentic. But reality, when it comes to this one, is there's a lot of errors, possibilities can come into this thing. So we need to make sure. So as I mentioned, 90% things may be right, but there could be a possibility of a few percentage errors in that one. That errors can cost you a few lakhs of loss if you are trying to do not only in terms of hardware cost, but also in terms of development time. Like if you are losing a cycle, means you are losing a 1 month time. For a startup who have like a 5 6 serious manpower working in a domain, and you're losing 1 month of their time, is you're getting a hit of something like a few 10 lakhs of kind of cost. So that is something which is not sustainable for a startup or whoever is trying to do this kind of development. So it is we need to be cautious about that thing. Then definitely one thing that we could use is if you are very concerned, it is maybe like a paranoia, or you can say that one. You can have a standalone AI LLM models. You can deploy it at your facility, provided you have a good GPU based computer, then server system. Then you can use that thing for your development. So that way you are not giving out all the queries or the prompt. Basically, that is a new programming language, basically, when it comes to. So whatever prompt that you are giving, actually you are giving out information to somebody else so that they can, yeah, that is basically what you are giving them. So that one, you don't have to give if you are using a locally hosted LLM. And definitely you should use this thing, but make sure that all the connections and everything is fine. And I would say whatever things that you know about the process or things that you need to take care during the layout. So that is know-how. That know-how you have to give to the LLM, then only it can do the things. For example, when you are routing a very low noise analog signal, you need to have the barriers, like what is stitching, those things. I'm not expert in that things. All those things needs to be provided. So these instructions have to be there in the prompt that you are going
Model.
to give to the. Otherwise, it is going to give you some GIGO, garbage in, garbage out. So just
Okay.
nobody is going to take care of the hard work that has to come from your side. That has to be there,
Yeah.
but it helps the process.
Yeah, understood. Any questions? Any other questions from the audience? I think they have been bombarded with all this information
Okay.
over the last 6 days. Yeah.
Hopefully, I didn't bore them to death, and
No,
I
not really.
didn't.
This was one like very interesting because it was like more from the overview, right, rather than going deep into technical. So it was interesting. And
Uh,
that was what I wanted as a last session. I hope there are no more questions. If there are any queries, Muni has shared his email, so you can get in touch with him. I'm sure he'll be ready to help you out. Once again, I thank Uni for taking his time and be with us, sharing his insights into this area. I hope at least you get you get an idea of what all concerns are there when this AI and security comes into picture from a product point of view. I hope that's a takeaway you can get. So thank you once again, Uni, and uh, we'll
uh,
wind
yeah.
up here.
Thank you, Professor Nalesh, for this opportunity, and all the students here. Please have a look at our website. It has listed only details about the precision automation thing. We are also working on the sensors and sensor system, as I mentioned. If any of you are passionate enough to, or foolish enough or dangerous attitude towards this thing to venture into this domain, please have a look at this thing and get back to us. I will be more than happy to hear from you. Thank you. Thank you all.
Okay, thank you. So yeah, you can sign out. Thank you.